You want to estimate how many fish there are in a pond. Suppose you capture 270 fish, tag them, throw them back into the pond. After a couple of days, you go back to the pond, capture 405, of which 27 are tagged. An estimate for the number of fish in the pond is. Now, this is weird. Let's just stop for a second and say, hey, this is weird, isn't it? Is this how they really do this? Actually, it is. This is modern science. This is exactly how biologists count fish in a lake, deer in the mountain or the forest, rabbits in the field. This is how they count critters. This is how biologists count critters, especially fish. If you now you think why do they count? Well, they need to count them. They need to they have to manage the conserve the wildlife health and population. Also, fishermen want to know how many fish are in this lake when they stock them, and then they have babies and some die and all that. So they do need to count fish in the lake, and how do they do it? I mean, even you might think, can't they just use their sonar? And no, they're all moving around. You're not gonna be able to count them with your sonar, those little dots moving around. So what they do is they actually do this mathematical probabilistic calculation we're about to do. This is exactly what they do. In fact, they call it the capture recapture method. You could go online and type in to Google capture recapture counting fish, and you'll get all kinds of articles on how currently biologists use these formulas to count the fish in a lake. Now, I've got a formula for you. It's in the notes, and we'll just crank it out. But I'd rather give you a feel. I mean, that's what's most important. You're going to become a teacher of other people in this material. So I want you to feel the truth of it rather than just blindly follow a formula. That's the best thing with math. It really is the feel. And I know that sounds weird to say, but the more you can, it makes sense to you, the better, the better. So let's try to make sense of it. And to make sense of it, let me give you some real easy numbers. What if instead of 270, what if they said, you went and you captured, let's see if I can make some nice numbers here. You captured 30 fish, and later you go back and capture 100, and you find that 50 of them are tagged. No, wait, that can't be. That's crazy. You tag, I don't know. You tag 100 fish. Let me try that. You go back later, grab 20, and 10 are tagged. Yeah, all right. Think with me on those numbers. I'm not going to write any math formulas. Just think with me. You tag 100. 2 days later, you let the fish all move around randomly. 2 days later, you net 20, and you look at them. You grab 20, you net 20, you look at them, and notice that 10 of them have tags from 2 days ago. Are you getting what I'm saying? So suppose that happened, real life. Let's just think real life for a minute. Suppose that you throw in a big net, you tag 100 and release them. So that's why it's called the capture recapture method. That's the official name the biologists use. It's called the capture recapture. So you capture them the first time. This is the capture. You capture 100, you tag them, you put a tiny little tag on them, and then you release them, throw them back in. And then 2 days later, you recapture at random. You just throw in a net, and at random, let me write the word random there. This is just a random net, right? You just throw a net down at random, and you happen to grab 20 random fish. You look at them, and you notice that 10 of those are the ones that had tags from 2 days ago. 10 of them are not. 10 of the 20 you grabbed at random on the recapture, half of them, 10 of them, have tags from the previous day. Now think about what that means. Just stop with me and think about what that means. So you grabbed 20, didn't you? You grabbed 20 the second day, and notice that half of them, 10, happen to be from the group that you had tagged a couple days before. They're previously tagged fish. So you did this totally at random. You just grabbed 20 fish at random, and 10 of them happen to be the previously tagged fish. So you know what that would make you think? This is just random, right? Those fish are just all swimming around random. You're thinking, well, probably half of the fish in the lake have tags, right? You see how I'm coming up with that? Because I just grabbed 20 at random, and half of my little group had tags, 10 out of 20. So probably that's reflective of the whole lake. Probably throughout the whole lake, half of the fish have tags. If I just grabbed at random with a net 20 and 10 of them, half of them had tags, probably that's how the spread of the whole lake is. About half the fish down there have tags. I just grabbed 20 and at random, and 10 happen to have tags. So probably 10 out of 20. So 10 out of 20, half the fish had tags when I grabbed them at random. So probably half the fish in the whole lake have tags. So what? So half of the fish in the lake. So probably, this is where it's an estimate. It's probably, this is where we're using probability. Probably about. Sorry, I'm writing fast. I don't want to spend too long in this, but so I'm scribbling. I'm writing like a doctor who writes fast. Probably about half of the fish in the lake have tags. Right? And that's just an estimate, but it's probably true, right? Because you grabbed 20 at random, 2 days later, you grabbed 20 at random and found in your little sample, 10 out of 20, half had tags. Well, it's probably the spread of the whole lake. Probably about half of the fish in the whole lake have tags. Okay, so what? Well, we know how many fish in the lake have tags because we tagged them 2 days ago, 100, right? We tagged 100 fish. So if there's 100 fish in the lake that have tags, we know that, we did it 2 days ago. And our little sample 2 days later is telling us that probably about half of the fish in the lake have tags. How many fish must there be in the lake? You see that? If there's 100 tagged, and we know about half of the fish in the lake are tagged, and there's 100 that are tagged, there must be about 200 total fish in the lake. See how that helped us estimate the number of fish in the lake? Do you feel the truth of that? Right? We tagged 100. 2 days later, we let them mix around. We randomly grabbed 20. 10 out of 20 had tags. Half. So we're thinking that was just random. So that's probably reflective of the whole lake. Probably half the fish in the lake have tags. Well, we know there's 100 fish in the lake with tags. If half the fish have tags, there must be 200 total fish in the lake. 100 have tags out of 200 total. So that helped us estimate the number of fish in the lake. And what we just did there, just kind of intuitively, is we really just did tag over total equals tag over total. We didn't formally do that, but that's what we were doing off the top of our mind. We were doing this, and this was from the first catch, or the capture as they call it, and the second catch, or the recapture as they call it. If you think about it, what we just did is we tagged 100 fish, right? We tagged 100 fish, and then on the recapture, we netted 20. 10 had tags, so that's 10 out of 20. 10 had tags out of 20 total on the recapture. And this is the part we don't know. X, we don't know the total fish that were in the lake when we were grabbing them the first time. That's what we want to find. And then how do you solve an equation with two equal fractions? You cross multiply. Do you remember that from earlier math classes? Even Math 10A covered fractions. You cross multiply. So that would be what? 2,000 is 10x. And then how do you finish solving for x? Divide by 10. Boom, boom. And so what is that number? X equals 200, which is what we just kind of estimated off the top of our head. That's what you do. That's what biologists do to estimate the number of fish in the lake. I hope it feels right and makes sense. I'm going to go back and solve these actual numbers with you now, but I hope that makes some sense. It's tag over total for first catch equals tag over total for second catch, capture, recapture. And then you just write in tag over total, tag over total. One of them is going to be an X. You cross multiply, solve for X, and that feels right, doesn't it? If you had 100 tagged, 2 days later, grab 20, 10 out of 20 have tags. That's half the fish in the lake. There's 100 tagged. There must be 200 fish in the lake. That's exactly what they do. So let's solve it now. Let's do that same thing now for the actual numbers. So all of that was just intro, but let's do the actual numbers they gave. Oh wait, it's not letting me. So I'm gonna have to oh wait, here, I can get it. I can do this. Just need to come down here and grab it again. And then I'll solve the actual numbers. But that's how you solve yours. Tag over total. It's tag over total. I'm grabbing it now. Okay, so now I'm going to do the actual numbers on this problem. So again, this is in the notes. Look in the notes right here. Here's what I'm saying. First catch, second catch, tag over total, then cross multiply to solve for X. Plug in 3 numbers and the X to the remaining spots. So there we go. So tag over total is tag over total. And this is the first catch. Second catch, capture, recapture, they call it in the official lingo. All right, so what we caught 270 and we tagged them. Notice those are all tagged fish. So that goes in the top. And then that's in the first catch, right? First catch. And then over here, we have, this is all the second catch. We capture 405, and this is all part of the second, and 27 are tagged. So that's 27 tagged out of 405. That's all in the second catch. And so then this is X right here. It's right. That's my last blank. That's X. And then how do you solve this? You cross multiply. So 270 times 405 is 27 times X. Hit the buttons on your calculator. I'm getting 109,350. It's 27x, divide by the 27 to finish solving for x. X equals, I'm getting 4050. We're estimating there's about 4,050 fish in the lake. So there we go. That is how biologists count fish in the lake. They also do it for deer on the mountain or in the forest or rabbits in the field. Same kind of thing. There we go.